Have you ever considered tuning your CAD workstation to gain more performance? And if so, can that overclock be stable? G'day viewers. Today we are taking a look at new PC components for a high performance CAD workstation, which we are building with the express intention to evaluate out-of-the-box stock performance against the productivity of a stable tuned system. Topics we will cover in today's video are why we are building a new high performance workstation, software considerations, our selected components, the PC build itself, and costings in Australian dollars. To explain why we are building this new workstation, I firstly need to highlight what has changed with our advanced steel workflow that has prompted this build. Over the past few years, we have developed and improved our documentation automation system, particularly for advanced steel. As a result, the SysDef Advanced Steel solution has allowed users to run automation processes to create a full set of engineering drawings and a full set of workshop drawings from a single script. For a small project, this might be 100 drawings. For a large project, you might need to create several thousand drawings. In either case, automating the process to create drawings will save users days, and on larger projects, weeks worth of work. So, why does this change require a new workstation build? Speed. Speed is the simple answer. These scripts can take 15 minutes to several hours to run. As a byproduct of the automated outputs, what has been interesting is the newfound ability to also use these automation processes for auditing of models. The benefit to the detailer is that it provides the confidence that once the 3D modelling is completed, the documentation is not going to cause any grief, as issues can be resolved during the 3D modelling phase and not discovered at the end, close to a delivery deadline. The downside is that the drawing automation process is no longer run just the once at the end of a project, but rather it is used several times throughout the project to audit 3D models. It assists with finding stray welds or stray bolted connections, incorrect model rolls, or drawing styles that may need to be tweaked. This new workstation will allow audits and 2D drawings to be created significantly faster than existing mobile workstations. Let us consider the software to be used on the CAD workstation itself. We use mainly the Autodesk AEC collection, which has Advanced Steel, Revit, Robot Structural Analysis, Navisworks, Recap, AutoCAD, and Dynamo. Plus, we use plugins for Advanced Steel such as the Graytec Power Pack, Titan Pro, Idea Statica, and iConstruct. Other software that I use are programs like Camtasia, DaVinci Studio, the Microsoft suite of products, and soon, hopefully, OBS. The core purpose for this new workstation is to run single-threaded CAD software, which we all know craves a high-frequency CPU. We also know that CPUs that offer the highest available frequencies typically have a lower core count, mostly due to thermal limitations. Although this workstation will be undertaking some video editing and rendering operations from time to time, which would benefit from having CPUs with a higher core count, its primary focus will be with advanced steel, modelling and automated drawing production. I think it's worth mentioning that both iConstruct and DaVinci Studio have functionalities that can take advantage of NVIDIA's GPU CUDA cores for parallel processing. Other than some GPU processing with Revit rendering, the majority of these other CAD software applications don't harness the available GPU resources and purely use the GPU for graphics display purposes on the monitor, which is most disappointing. I haven't started to use OBS in my current workflow, so I don't have much insight into its resource utilization. If anyone has experience with OBS and whether it uses GPU or CPU processing, I'd be interested to understand that software application resource needs. If you have any advice, post your comments below. Rightio, let's get serious now and start reviewing these exciting new PC components. This PC build will be known as AB, also known by some as Captain Cranky. Here is an overview of AB's build specs. For the chassis, we have gone with the Leon Lee Dynamic 011 Evo. For the motherboard, we've gone with the Asus ROG Maximus Z690 Extreme. The processor, we have chosen the Intel Core i9 12900K processor. For the CPU cooling, we have gone with the Asus ROG Ryzen 2 360 all-in-one liquid CPU cooler and 9 Leon Lee AL120 fans. The RAM, we have gone with 64 gig of G.Skill DDR5 RAM at 6000 MHz. For the GPU, we have gone with the NVIDIA Quattro RTX A4000. For storage, we've got two 2TB 980 Pro M.2 SSDs in a RAID 0, plus one scratch drive, which is also a Samsung 4TB SATA SSD. The operating system, we are using Microsoft Windows 11 Pro. The power supply, we have selected the Corsair HX1000, which is a 1000 watt platinum PSU. Thermal place, the Noctua NT H1 thermal paste. With monitors, I've gone with one Dell 43-inch ultra sharp 4K monitor, model number U4320Q, plus two Dell 27-inch 4K monitors, model number P2721Q. So that is a quick overview of the parts that this workstation build will have. I will go through the parts list in the order I made my decisions. I found this selection method assists with the process of elimination when selecting the components. Other factors that played a part in the selecting of components were availability and which brand some suppliers held. Initially, I had selected 3 potential PC part suppliers, 2 that were local bricks and mortar stores and 1 that was an online national supplier, with the intention of ordering from whomever had the best price for each specific component. In the end, that proved to be more challenging than the value that it offered. So in the end, 95% of the components were purchased through the one supplier, with only the DDR5 RAM being difficult to source and purchased through a separate supplier to ensure we had those components available in time for this build. GPU stocks were still proving to be difficult at the time of this build, which is late February 2022. However, I was lucky and I didn't have an issue with sourcing my GPU at the time of this build. Thanks for watching the video, and be sure to check out our other videos on the channel. Also, click the like and the subscribe buttons below. Leave us a comment if you have any questions about Advanced Steel, or if there are specific topics you would like us to cover. And remember, if your job's worth doing, it's worth doing right.